All right, so here are the answers to your quiz, and I hope that you'll go by item and pay attention to those items that are giving you trouble. What should you do? Go to that section in the book and work odd problems from that section. You got to work problems. It's the only way that you're going to get there. So you can go back and watch the quick review videos. You can go to www.afterschoolhelp.com as well and get help there. All right, I need to get going here. This is my second take. I got almost all the way done with the first one and realized that it stopped recording. All right, well, let's go. Here we go. When nothing is shown in the crevice of the radical sign, the value is 2. The index is a 2 when there's nothing in the crevice, right? Like if I had this, the square root of 7, the index that is not shown is a 2. All right, 1b, everything under the radical sign is called the radicand. Radicand, it's just terminology. Make sure you have a D at the end of that word. The number in the crevice tells you what kind of root it is and is called the index. It's really important that you pay attention to the index. Hey, an index of 2 is a square root. What number times itself 2 times equals the index? A cube root, the index is 3. What number times itself 3 times equals the radicand? So you got to pay attention to the index. All right, when multiplying radicals, always look to simplify before you multiply. If you multiply, you'll have to unmultiply to simplify. So do it before you multiply. It's just a time thing. Sigma notation is used to represent the summation. Summation. S-U-M-M-A-T-I-O-N, which, by the way, you could also say the sum. I'll take that. You could say the adding. I'll take that. You could say the addition. I'll take that. Summation, summing, adding, addition. Any of those 4 words will work in that blank. When a radical is in the denominator, blank the denominator, simplify it. The word is rationalize. Rationalize. That's the term there, and that's the term that you should know. Rationalize the denominator. All right, finish the rules. So the first rule is multiplying radicals. Coefficient times coefficient. Radicand times radicand. Don't forget the index. 2b, how do you divide a fractional radicand? It would be the root of the top divided by the root of the bottom. All right, so the nth root of x. Do not try to rationalize this. You can't, because of the nth root, we don't know what n is. We don't know if it's 2, 3, 4, 8, and that would matter. So you can't rationalize that rule. All right, 2c, what do? You got to add the coefficients or subtract. Oops, let me catch that. B, subtract the coefficients. So you need this parentheses. It has to be there. A plus B if you're adding, A minus B if you're subtracting of the nth root of x's, right? You're figuring out how many of them you have. That's it. Okay, the rule. Convert to exponent form. So you must know this rule. The b root of x to the a equals x to the a divided by b power. So if you know that rule, then you can simply convert all these. So number 3a, n, and the fractional exponent has a 3 divided by the index 4, so n to the 3/4. b, the 1 is not shown for the 7, and the 2 is not shown for the index, but it gives you 7 to the 1/2 power. C, be careful now, this is a 5 to the 1st times an x squared. So it's 5 to the 1/3 times x to the 2/3. Now you can have a raised dot between them, but you don't need it. 5 to the 1/3 x to the 2/3. All right, to convert to radical form, now we're going the opposite direction. We're going to take this and go back to that, right? So 3's was going one direction, and number 4 is going the opposite direction. All right, so for 4a, I know my index is 5, and I get n to the 4th. That was real similar to 3a, wasn't it? It really was. All right, b, I see my index is a 4, right? Both of those have 4 for an index, so 4 is my index, and I get 3 squared a cubed, and I'm not done. So if you did that, you're going to get just a minor deduction. You always want to turn numbers into the pure number that they are. 3 squared is a 9. So the fourth root of 9, a cubed. Don't forget the index. A lot of times students forget the index. Okay, for 4c, I need a common denominator. Well, I can get a 2 on the bottom here to be a 6 by multiplying by 3. Whatever I do to the bottom, do the same thing to the top. So here's where I'm at right now. I have 5 to the 1/6 times x to the 3/6. Do you see now how the denominators match? And that's going to be your index. Whoops, I wrote a 3 and I circled the 6, right? That's going to be the index. And then I have 5 to the first power. I don't write the 1, right? And then x cubed. So the 6th root of 5x cubed. All right, simplify. So you got to pay attention to your index. This is a cubed root. What number times itself 3 times equals the index? Well, you might know the cube root of 8 is 2, but why is it 2? An 8 is a 2 times 4, and a 4 is a 2 times 2. What number times itself 3 times is an 8? Well, a 2 times itself 3 times is an 8. By the way, I could have written it like that, 2 cubed, right? And whenever the exponent matches the index, the root is the base. Why? Because you have that the thing times itself, the amount of times of the index equaling the radicand. All right, so those are all gone, so there's nothing left, and it's just a 2. Number 4, or 5b, the index is 4. What times itself 4 times? Oh, look, I have a 5 times itself 4 times. So the 5th root of 5 to the 4th is 5. Now, how do I do the second part? Because the 12 is divisible by 5, I can say n to the 12 divided by 4. 12 divided by 4 is 3, and I get n cubed. So that's one way of doing the problem, and I just took care of it. The other way is to get the exponent to match the index. Okay, I just used 4 of the 12 n's. There's 8 of the 12 n's, and there's 12 of the 12 n's. What's the 4th root of that? N. What's the 4th root of that? N. What's the 4th root of that? N. What's n times n times n? N cubed. And that's why the answer is 5n cubed. Okay, 6, I'm making sure it's still running this time because I don't want to get all the way done again and have to redo it. Okay, so the square roots, you got to pay attention to the index. This is a square root. The index is 2. So what times itself 2 times equals the radicand? All right, the 18 is a 2 times 9. Most people know that the square root of 9 is 3. Again, why is it a 3? Because a 9 is a 3 times 3. What times itself 2 times is a 3 times 3? A 3. All right, the n, I don't have enough of them. I only have one n. It's going to have to stay in there. But look, I have p squared. What's the square root of p squared? P. And everything else stays left in. What do I have inside? I still have the 2 inside. I still have the n inside. 3p times the square root of 2n. 6b. Oh, I have a 6 index. So I need something times itself 6 times. Well, look at my 5s. I have 7 5s. I want 6 5s. But I have 7, so it's 5 to the 6 times 5. So I just changed the form right now. Now I'm going to take the root. What's the 6th root of 5 to the 6th? 5. Again, what number times itself 6 times is 5 to the 6th power? A 5 times itself 6 times is a 5 to the 6th power. Whenever the index matches the exponent, the root is the base. All right, that 5 is left. Can't do anything with it. How about my a's? Well, I have 9 of them. So again, I want 6. I want to match the index. And there's 6 of them, so I have 3 more, right? There's the 9 of them. And what is the 6th root of a to the 6th? It's a, and I get an a out. Okay, my a's are done. Now the b's. Because the 12 is divisible by 6, I can do the shortcut. A to the 12 divided by 6, or I'm sorry, b to the 12 divided by 6 is b squared. That's one way of thinking of it. The other way is to do b to the 6th, I use 6 of them, times b to the 6th, there's the other 6, or 12. What's the 6th root of b to the 6th? B. What's the 6th root of b to the 6th? There's the second b for b squared, 5ab squared. Okay? All right. Multiply or divide. Simplify if possible. So remember, S-bump. Simplify before you multiply. This is just a shortcut because they're all going to end up underneath the same radical. We have square root times square root. So notice a 10 is a 2 times 5. So here's 1, 2. There's a second 2. And what's my index of 2? What's the square root of 2 times 2? It is a 2. I get a 2 out. Now notice I have 1x and there's a second x. What's the square root of x times x? It's x, and I get an x out. Now, all of this is a shortcut. Now, let me show it to you to doing this. 2 squared times 5 times x squared times y, right? And so up above, what do I have left? I have left inside the square root of 5y. Well, doing it down here, what's the square root of 2 squared? 2. What's the square root of x squared? X. And what's left in? 5y. See how you get the 2x times the square root of 5y? I hope you do. All right, 7b. So now I know I have to take the square root of the top divided by the square root of the bottom. Okay, square root of the top is square root of 3. It just stays that way. Don't turn that into, don't punch that into your calculator. I don't know, the number's like 1.4 something, but we want it exact, so leave it square root of 3. You can have a radical in the top. You cannot have radicals in the bottom. Now, the bottom is nice. What's the square root of 49? 7, right? Because 7 squared, 7 times 7 is 49. And what's the square root of y squared? It's a y. And the answer to 7b is the square root of 3 over 7y. All right, 8a. So again, I got to split it up, square root of 9 over the square root of 5. Now, by the way, you should know the square root of 9 is a 3, right? But my problem is the bottom. I have to rationalize the denominator. I got to get rid of that square root in the bottom. I have a square root of 5. If I multiply it by another square root of 5, I'm going to end up with a square root of 25 on the bottom, and the square root of 25 is 5. See, I got rid of the radical. But to make it legal, whatever I do to the bottom, I must do the same thing to the top. So where do I end up? Top, 3 times the square root of 5, and the bottom is a 5. So you might say, well, how'd you get that 5 on the bottom again? Let me show it to you over here. So again, there's the top, right? 3 times the square root of 5, and the bottom is the square root of 5 times 5. And again, can't you take the square root of a 5 times 5? It's a 5, and you get 3 times the square root of 5 over the 5. We rationalize the denominator. All right, a is a bit different because it's a cube root. You always have to pay attention to your index. So first off, we got to split this up. I'm going to do it down here. So this is the cube root of 7 over the cube root of 4x. Now, when I have a cube root, I know I need something times itself 3 times. If you go back to this problem, I had a square root. The index was 2. What times itself 2 times? I had 1 5. I needed to supply a second. But in this problem, I'm doing a cube root. Oops, wrong way here. Come on. I'm doing a cube root. And so now I got to think what times itself 3 times, right? And it's only the bottom I'm worried about. I'm rationalizing the denominator, So first thing I want to think about, let's make the 4 a 2 times 2. Because here's the issue. I have to deal with the number and the variable in the denominator. And I got to multiply by a cube root. Now again, what's the index? 3. How many of something do I need? 3. How many 2's do I have? 2. How many more do I need? 1. So I'm going to multiply by cube root of 2 to get that third 2. Now look at my x's. How many x's do I have? Just 1. How many do I need? 3. So therefore I need 2 more or an x squared. So to rationalize, I must do it times 3, the cube root of 2x squared. Whatever I do to the bottom, I do the same thing to the top. Okay, let me use a little color here. Top times top. And the top ends up being the cube root of 7 times 2 is 14 times x squared, or 14x squared. On the bottom, watch my color. What's the cube root of 2 times 2 times 2? Answer, a 2. What is the cube root of x times x times x? Answer, x. And you get the cube root of 14x squared over 2x. And you cannot reduce that x and one of those x's, nor that 2 and those 14s and that 14. Why? Because this is the radicand. It's all underneath this radical symbol. And so you can't reduce. If you would have had a number out front, we didn't. If I would have had a 10 out here, I could have done the 2 and the 10 out front. But there was no 10 there. And that's the answer. Cube root 14x squared over 2x. Okay, 9a is pretty simplistic. 5 of them plus 7 of them is 12 of them. Ooh, and I just noticed a simplification. So you got to be careful. All right, so can't we take the square root of 4? And what is it? It's a 2, and we get a 2 out. So the final answer should be 24 times the square root of a. That's the completed answer. Hey, if you didn't catch that, just a minor deduction, but always be on the lookout to simplify, right? And just notice that as I was doing the problem. Okay, on 9b, your first thought might be, I cannot subtract these because, here, let me do it this way. Because I have a square root of 5y and I have a square root of 20y, and they don't match. But remember, always look to simplify. So watch what happens when I simplify this 20. It's a 4 times 5, is it not? And what's the square root of 4? 2. See how I get a 2 multiplier out? So let me show you where I'm at. The front is 3 times the square root of 5y. Then we have that minus sign. We have 5 times 2 is 10. And then we have the square root of 5y. Now do you see what you have? Let me use my color again. 3 positives and 10 negatives leaves you 7 negatives of them. And what are they? They are square roots of 5y. So 9b would be negative 7 times the square root of 5y. All right, a couple more to go here. Number 10, you have to notice the distributive property, right? A times the quantity b plus c equals a times b plus a times c. So first off, I must multiply this times this. This is pretty straightforward. You don't see the 1 in front of the square root of 7, but it's there. 2 times 1 is 2. And square root of 3 times square root of 7, 3 times 7 is 21. That's the front. Now here's where you got to be careful on the back. Watch what happens. 2 times negative 5 is negative 10. Agreed? But watch with the radicand. You get the 3 times the 6. And notice the simplifying that's going to take place here. I'm going to use red, right? A 6 is a 2 times 3. You notice how we have the 2 3's. What's the square root of 3 times 3? It's a 3, and a 3 comes out. So what is my final answer? 2 times the square root of 21 minus 30 times the square root of 2. And you could have had it in the other order, negative 30 times the square root of 2 plus 2 times the square root of 21. All right, just distributing and simplifying, so be careful with those. Okay, do you remember how to do summation? So if you remember the formula, what I told you was you have to average the first term, a sub 1, and the last term, a sub 50. You got to divide by 2, and you got to multiply it by n. So that's the formula. So n is 50. What's the first term? All right, let me do this off to the side. A sub 1 is when the n is a 1. 4 times 1 is 4. 4 minus 1 is 3. Okay, so a sub 1 is 3. Here I'm going to do it in black. I'm going to do a sub 50. Now where the n is, I put in 50. 4 times 50 is 200. 200 minus 1 is 199. So this would be plus 199. And all divided by 2. And so basically it's 25 times 202. Punch that out in my calculator. 5,050 is the answer to that question. 5,050. All right, last bonus. So this one has some interesting aspects. Remember last chapter in factoring? Now, you can only simplify things being multiplied. And right now, everything's being added. So first thing I want to do is I want to factor out the common 4. So that leaves me an x squared minus 4xy plus 4y squared. Does that make sense? I'm going to further factor the trinomial. 2 parentheses. So x and x, right? And I have a 4y squared and a negative 4 in the middle. So negative 2y, negative 2y. When I check my outers, I get a negative 2xy, and my inners another negative 2xy for the negative 4xy. So here's where I'm at right now. I have 4 times x minus 2y quantity squared. Okay, what's the square root of 4? 2. What's the square root of x minus 2y squared? Anything times itself twice, the root is the base, which is x minus 2y. Final answer, distribute this out. 2x minus 4y. If you get this, you're understanding last chapter well, you're understanding this chapter well. If you didn't get it, it's understandable. It was a difficult bonus, but I hope you did. I hope that you understood the things that we've done. Again, www.afterschoolhelp.com. Have you been reading every lesson like I've been assigning? Have you? Have you? When you're doing the homework, are you actually stopping after each odd to see if you're understanding? Are you learning from the homework? This is the idea of homework, so you'll learn. That's why I'm giving you odds, so you'll have the answer. You got to go back, look at your notes, find a similar problem, figure out what you're doing wrong. You got to figure it out. Are you watching the quick review videos? There's help for you. I know it's tough being at home, but there is help, and you need to take advantage of it. All right, you can if you want to. I hope you want to. Hope you have a great test in just a couple days. So use this review, use the chapter review. If you haven't watched the chapter review yet, make sure you watch chapter review. It's right after this video. And get yourself prepared for that test. Same scenario. You'll have until 3 p.m. the day that I give the test for you to complete it. Please make sure you pass those in to me. Hey guys, when you do your test, make sure I can see your name. And if you can, use the PDF function on your iPhone if you've got one. Boy, it's so much easier for me to get them from a PDF. But if you need to, use the photo function, but PDFs are great. Okay, hope you have a great day.